Example 4. Now let's look at what's called the residual plot. So it says graph and analyze the residual plot of the salary study data in example 1 to determine whether the linear model found in example 3 is appropriate. And so what does that mean? Well, if you come over here to the regressions, you go to linear here, I'm going to click this on the residuals E1 plot, that button plot. And what happens is, and I'm going to need to zoom out here, you get this residual plot, and what's happening, and we need to ignore that, the t statistic for a moment, is what it's doing is it's showing you each individual data point. So each one of these data points here, it's showing those, and let me just change color so you can tell exactly what we're looking at. Each data point compared to the regression line. So here's your regression line. We're going to take a look at each data point compared to the regression line. And so the ones below mean that this particular individual or data point was making below what the graph or our line, our regression model would predict. Each one above would be representing someone who made more than what the line would have predicted. And so what you would want, if it was a perfectly accurate, every single point would be on the x-axis here, but because they're scattered pretty evenly as you look at it, this represents that it's a very appropriate, model. Model is appropriate since your residual plot is very, I'm going to use the term symmetrical here. And maybe I shouldn't say very, but I'll just say since it's symmetrical. And so really what you're looking at is this portion of the graph right in here. Let me get some, that's what we're looking at and saying, because these are pretty symmetrical, this model would be appropriate. Now let's check your DOL. Again, you're using the same data from the previous examples. And so you're going to look at, are they randomly scattered or do they not appear to be randomly scattered nor centered?